Hello, my dear students. My name is Mr. Muhammad. I'm going to be your science teacher. Today's lesson is about mixture and solution. Today, we're going to differentiate between mixture and solution. What the difference between mixture and solution? What the meaning of mixture and what the meaning of solution? What the meaning of mixing? Okay, can you tell me what the meaning of mixing or what do you know about mixing? Okay, that's right. So mixing like mixing colors, right? For example, imagine that there is an artist, he wants to use a specific color, okay? But do you think the artist has a bag which is filled with thousands of colors and he choose the specific color that he needs to use? Sure not, right? So if he needs a purple color, as you see here in the picture, he's gonna mix red and blue, right? If he needs a green color, he's gonna mix yellow and blue and so on, right? So mixing like mixing colors to produce a different color. Okay, so here we have a question. How could you make different colors of icing for a cake? Easy, by mixing different colors together to produce a new color. Now, here you see different colors are produced by mixing. See? Okay. That's how mixing colors produce different colors. It's mixing. Now, the mixture. Okay. Mixture, as you see here, we have a mixture of peanuts and raisins. As you see, when I mix raisin and a peanut together, I put them beside each other. Does it produce a new substance? Does it become a new substance? No, it's the same, right? The raisin is raisin and the peanut is peanut. Both of them keep its own properties, right? That's it. So mixture is mixing different materials that placed together, but each material in the mixture keeps its own properties. In the nut and raisin mixture, you can easily separate them. You can just pick up the raisin if you need, or if you prefer the raisin, or if you prefer the peanut. It's easy just by picking. You can differentiate between them and pick up and separate each of them easily, right? That's the mixture. So mixture is mixing different materials together, but they don't produce a new substance. They don't combine chemically. Each substance keeps its own properties. Each material keeps its own properties. There is no new substances produced. It's the same substance. Each substance keeps its own property, and it's easy to separate them by easy ways. Okay, here is a video about mixture and how to separate them.
Favorite. That doesn't make any sense.
I don't know. I like mix. Hey, birthday girl.
Sam, what's up? I'm just setting out some munchies for the party.
Sweet. I brought the cake Mia and I made.
Aw, this is awesome. You guys rock.
Okay, let's continue the video later. I'll upload for you the video. Okay, and then this rock is called iron ore. Iron ore. What this? This is a mixture of iron and different components are mixed together. Okay, so I produce, as you see, this rock, as you see in the picture. This rock is called iron ore. It's a mixture of iron and other substances. Okay, so do you think is it easy to separate it? No, actually, it's hard to separate iron from iron ore. It needs a lot of energy. That's why here factories use a lot of energy to separate the iron from iron ore. As you see here in the video,
Iron is the fourth most common element in the Earth's crust, composing about 5.5% of it by weight. Yet, to be potentially profitable to mine, iron needs to occur in very large concentrations of upwards of 25% by weight. While this can occur in some select igneous and metamorphic rocks that have instances of the minerals hematite and magnetite in matrix, the latter of which, as the name implies, is magnetic, much of the world's iron ore instead comes from something different, a type of sedimentary rock. Iron is the fourth most common element in the Earth's.
Okay, that's enough now, and you can watch the video later. So, as you see, mixture is mixing substances together, and you can't separate them, okay? Maybe it's easy or almost it's easy to separate them, and some mixtures are hard to separate, such as iron ore. So again, let's recap the mixture. Mixture is mixing different substances together, but it does not produce a new substance. Each substance keeps its own properties. There is no new substance is produced. And it's easy to separate the substance by picking or by easy ways, okay? Now, solution. Solution actually is a kind of mixture, but there is a difference between solution and mixture. But remember, solution is a kind of mixture. Solution is a kind of what? Yes, solution is a kind of mixture. So solution, such as dissolving salt in water. Try to dissolve salt in water, okay? Can you see the salt particles after dissolving? No, it's dissolved, it's spread out evenly in water. I can't see it anymore, but you can separate it, right? So when you dissolve sugar in water, can you see sugar particles after dissolving in water? No, I can't. So it's called a solution. It's kind of mixture, but the particles spread out evenly in all directions of the solution. That's why it's called solution. So solution is a mixture in which substances are spread out evenly and don't settle to the bottom of the container. Again, solution is a mixture. It's a kind of mixture, but the components or the substances are spread out evenly in all directions, and you cannot observe the particles by your naked eye after dissolving. So the substance in which the solute is being dissolved is called solvent. Listen, here I have water and salt. When I dissolve salt in water, the salt is called solute. The salt is called solute. The substance that I dissolve in water is called solute. And the substance that dissolve the solute is called solvent. The substance that dissolve the solute is called solvent. So again, here I have water. When I use water, it's called a solvent. I use water to dissolve salt inside it. So water is called solvent. Water is called solvent. If I use milk and I put the sugar inside the milk, so the milk is solvent. The milk is solvent. If I have a juice and I want to dissolve sugar in the juice is, for example, apple juice or orange juice. The juice is solvent. And the sugar that I dissolve in the solvent is called solute. It's called what? Solute. So I use sugar and I dissolve sugar in milk. I dissolve sugar in tea. So the sugar is solute. The tea is solvent. Other example, I'll ask you, if you dissolve salt in soup, the salt is what? Yes, good job. It's solute. And the soup is what? Solvent. Great job. Thank you. Perfect. So again, solute is the substance that you dissolve. Okay, like sugar, like salt, you dissolve sugar in water, you dissolve salt in water, so it's called solute. And the solvent, water, milk, juice, the substance that you dissolve the solute inside it. Okay, the last point, stirring or heating. If you stir the solution, does it speed up the dissolving process or does it slow down the dissolving process? Yes, that's right. Good job. It speeds up the dissolving process. So if you want to speed up the dissolving process, you can stir. You can what? Stir. Again, you can what? Stir the solution. Or you can heat the solution. You can what? heat the solution. So again, you can stir the solution or you can heat the solution so it speeds up the dissolving process. And finally, grinding the solution or grinding the solute that you dissolve in the solution. For example, I have a sugar cube, okay? Which one is faster if you have a sugar cube and you dissolve it in a cup of water, or if you have a sugar powder and you dissolve it in a cup of water? Which one is faster? Think about it. Okay, in the group, you can discuss as a group now and tell me which one is faster in dissolving. Sugar cube is faster in dissolving, or sugar powder is faster in dissolving? Okay, go ahead. Yeah, that's right. Perfect. Sugar powder is faster. Sugar powder is faster in dissolving. So when you grind the solute, it becomes faster to dissolve in the solution. So we have three factors affecting the dissolving process or speed of the dissolving process: stirring, heating, and grinding. Stirring, heating, and grinding. Repeat after me. Stirring, heating, grinding. Stirring, heating, and grinding. Stirring, heating, and grinding. Perfect. Thank you. Now, first question, raise your hand. The substance that's dissolved in the solution is called. Okay, go ahead. The substance that's dissolved in the solution. Solute. Perfect. Good job. Thank you. The substance in which the solute is being dissolved is called. Okay, go ahead. Solvent. Perfect. Thank you. And finally, how can you dissolve the solids faster in the solution? Think about it. Okay. Yes, grinding. Yep. Stirring. Yeah. Heating. Perfect. That's it. Okay, that's all we have today. So let's recap again. We studied today mixture. Okay, it's mixing different substances together, but does it produce a new substance? No, it doesn't produce a new substance, and each substance keeps its own properties. Can you separate them easily? Yes, sure. By picking or by an easy way, I can separate most mixtures. And we studied also the iron ore, and we said that it needs a lot of energy to separate iron from iron ore. And then the solution. Is the solution a kind of mixtures or not? Yes, it's a kind of mixture, yeah. But what the difference between the solution and the mixture? Yeah, that's right. Solution particles of the solute are spread out evenly everywhere in the solution. That's why I cannot observe by my naked eye. And how can I speed up the dissolving process? Yes, stirring, heating, and grinding. Good job. Okay, thank you, and see you next time, inshallah. Bye.